Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start third lecture of Module 3. The topic of the lecture is wind system, their classification and primary wind circulation. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lecture, we have discussed in detail what are winds and how does the general circulation of winds affect the global climatic pattern and what is the general significance of winds. In this particular video, we will be proceeding further and we will be classifying the winds based on their sphere of influence. And herein we will be discussing the planetary wind circulation which exists on Earth. So let's begin. In the due course of this video lecture, the learners will be able to understand general classification of winds, which will be bifurcated into planetary wind system, regional wind system, and local wind system. So as you can see that the topic on general classification of winds is quite extensive. Therefore, we will be covering each and every subsystem in a separate video lecture. So in this particular video lecture, we'll be focusing on understanding this planetary wind circulation on Earth. And in the subsequent video lectures, we'll be covering regional wind system also and local winds also. And then finally, in this video lecture, we'll be discussing shifting of pressure and wind belts and associated climatic significance. How does the shifting of pressure and wind belts impact the climate at the local level, global level, or even at regional level? So we will see their significance. So let's start with the general classification of winds now. Now starting with the classification of winds. On Earth, winds are broadly classified into three categories, and this classification is based on the periodicity of occurrence and the location of occurrence. So depending upon the dimension at which the winds are blowing and on the periodicity of their occurrence, the winds are divided into three broad categories. First one is the primary winds or planetary wind system. Second is the secondary wind, periodic winds or regional wind system. And third one is the tertiary wind or local winds. Primary winds or planetary winds. So these types of winds constantly blow throughout the air in a particular direction, having global dimension. So they are macro scale winds having global dimension and they constantly blow throughout the air in a specific direction, because of which they are also known as planetary winds because they have planetary circulation, and they are also called as prevailing winds. So few most commonly observed planetary winds are the trade winds, the westerlies, the easterlies, and they cover specific latitudinal dimension on our planet depending upon the low pressure and high pressure belts that exist on Earth latitudinally. So besides the primary winds which have global dimension, you have secondary winds which are regional in nature. They cover much wider area, but their circulation is not at global dimension, but still they may cover wide area on Earth. They periodically change their direction in different seasons and occur in many locations throughout the world, and they are greatly influenced by the regional condition. As the name suggests, these type of winds periodically change their direction and they are highly influenced by the regional conditions. So one of the best examples of secondary winds are the monsoon winds, because these type of winds are the result of 180-degree reversal of wind systems, and they periodically change their direction. So we will be discussing each one of them in the coming videos. This is just a brief description of what all the three types of classification of winds are, and in general how do they differ from each other. The third one in this continuation is the tertiary wind or the local wind system. Tertiary winds blow only during a particular period of day or specific time period in a year, specifically due to differences in temperature and air pressure of a specific region. So they can be hot, cold, ice-filled, dust-rich, depending upon the local characteristics or local conditions which influence them. So few recognized local winds are Loo, which blow in the northern Indian plains in the summertime period. Then you have some European winds also. You have Mistral, you have Fohn, you have Bora, and they are greatly dominated by the local conditions which are found in certain parts of Europe. So you have three types of winds: primary winds and secondary winds and tertiary winds. But in this particular video lecture, we will be just taking up the planetary wind, and we will be discussing them in detail here. And in the coming subsequent lectures, we'll be discussing the secondary wind systems as well as the tertiary wind systems also. Let's see what are primary winds or planetary winds. Primary winds or planetary winds. These are global dimensions wind circulation which originate primarily because of the existing thermally and dynamically induced latitudinal pressure belts. So we have already studied in the last video that because of thermally induced conditions and dynamically induced conditions, you have 7 pressure belts around the globe which have latitudinal extent. So you have one pressure belt, which is equatorial low pressure belt located near the equator. Then you have the subtropical high pressure belt, which is located at 30° in both the hemispheres. And then you have the subpolar low pressure belt, which are again 2 in number and located in both the hemisphere. And finally, you have polar high pressure belt, which is also present in both the hemispheres. So you have 7 pressure belts in total, in which the polar high pressure belt and equatorial low pressure belt are thermally induced, and then subpolar low pressure belt and subtropical high pressure belts, both the belts are dynamically induced in both the hemispheres. So the planetary wind movement is specifically from the high pressure belts region of the world near the Earth's surface to the low pressure belts regions of the world. So whatever wind circulation we are going to discuss now, it is confined to the regions near to the Earth's surface. So whenever we talk about the planetary wind circulation, we talk about the general wind circulation near the Earth's surface. The direction of such winds remain more or less stationary throughout the year depending upon the pressure belts, though the area may change seasonally. On an average, the pressure belts remain stationary, but with the apparent northward and southward movement of the sun, with the summer and winter solstice, the pressure belts, they tend to migrate northward and southward respectively. During that time period, the winds, although may follow the same nature direction, but their area may change seasonally. It may migrate northward or southward. So these winds are known by different names. They are named as planetary winds, primary winds, prevailing winds, permanent winds also, or invariable winds also, because they are more or less permanent in nature. They blow throughout the year and their circulation is permanent. They are not variable in nature. They are constant in nature. They are constantly blowing. So they are called as invariable winds also. So the winds that flow throughout the year from one latitude to another, specifically from high pressure belts region of the world towards the low pressure belts region of the world, because of the latitudinal differences in the existing pressure conditions and covering vast area over land and oceans are called as planetary winds or primary winds. Primary winds or planetary winds are further divided into three broad categories. First is the winds in the tropical areas or along the tropics, which extends from 30° north to 30° south in both the hemispheres. So within this belt, you have major two winds. First one is the trade wind and second one is the equatorial westerlies in the tropical region. Second subtype is the winds in the temperate latitudes or the horse latitude, which extends from 45 to 65° latitudes in both the hemispheres. So you have westerly winds which are blowing in these regions. The third category of winds within primary or planetary winds is the winds in the polar latitudes, which generally extend between 70 to 90° north and 70° south to 90° south in the southern hemisphere. In these regions, you have polar winds which are blowing, which are also called as polar easterlies. So let's understand these winds in detail now. Winds in the tropical areas. The winds blowing between 30° north and 30° south in both the hemispheres are called as tropical winds, which exist in these regions. Two types of winds are primarily found in these regions. First one is the trade wind and second one is the doldrum and equatorial westerlies. So before starting or understanding the wind circulation in the tropical areas, you have to remember at the back of your head the existing pressure belts also. So you have equatorial low pressure belt and you have subtropical high pressure belt in both the hemisphere. This is the tropical zone, which extends between 30° north and 30° south. And the winds blowing in these regions of the world are called as tropical winds. And first among them are trade winds. Near the Earth's surface, the winds which blow from subtropical high pressure belt towards the equatorial low pressure belt in both the hemisphere are called as trade winds. But because of the Coriolis force, the winds are deflected towards their right in the northern hemisphere and towards their left in the southern hemisphere. Therefore, the direction changes. The direction now becomes northeast and southeast. So you have northeast trade winds which blow from north subtropical high pressure belts towards the equatorial low pressure belt, and you have the southeast trade winds which blow from southern subtropical high pressure belts towards the equatorial low pressure belt. And these winds, they are attracted towards this low pressure central core region, which is the equatorial low pressure belt. But once they converge near the equatorial low pressure zone, their convergence zone is called as intertropical convergence zone, where the northeast trade and southeast trade winds, they converge. But they are not properly able to converge because of intense insolation at the ground surface near the equatorial areas. Because of intense insolation, as they merge, they ascend due to convection towards the upper regions of the atmosphere, and in the process they cool down, causing precipitation in these equatorial regions of the world extending between 0 to 10° north and 10° south in both the hemispheres. Primarily, the trade winds blow from east to west in the tropical zone, and they converge along a zone which is called as intertropical convergence zone, which is not stationary. It migrates northward and southward with the apparent northward and southward movement of the sun respectively. So when you have summers in the northern hemisphere and the sun is directly overhead the Tropic of Cancer, the ITCZ shifts northward it becomes North Intertropical Convergence Zone. So trade winds now they merge along this particular convergence zone, and again when you have winters and the sun is over the Tropic of Capricorn in the southern hemisphere, the ITCZ again shift southward, and then the trade winds they converge at this particular ITCZ. So intertropical convergence zone keeps on migrating with the apparent movement of the sun as the earth revolve around the sun during a period of 1 year, and you have summer solstice and you have winter solstice. Once these trade winds they converge at the ITCZ, they tend to rise due to intense insolation near the equator, and on rising they condense, causing heavy precipitation in these regions, especially along the eastern margins of the continents. As you can see in the diagram, the northeast trade winds coming from the northern regions and merging at the equatorial low pressure belt. Similarly, you have the southeast trade winds coming from the southern hemisphere and merging at the equatorial region. So once they converge in the ITCZ zone, they automatically ascend in the upper atmosphere. And once they ascend in the upper atmosphere, during this process, they cool down, and because of the presence of high pressure in the upper regions of the atmosphere above these areas, the wind tend to diverge in the opposite direction. So the high pressure zone in the upper atmosphere leads to aloft air divergence, leading to the formation of antitrades which blow in opposite direction in both the hemispheres, and these antitrades they subside at 30° north and 30° south in both the hemispheres, leading to the formation of high pressure belt. So you have subtropical high pressure belts because of descending antitrades from the upper atmosphere, and these descending antitrades leads to the formation of anticyclonic conditions in both the hemisphere, in the northern hemisphere as well as southern hemisphere, leading to divergence of air at the ground surface. So trade winds actually are the surface winds which blow from subtropical high pressure belt regions towards the equatorial low pressure belt regions in both the hemisphere. As the trade winds blow from the subtropical high pressure belt regions towards the equatorial low pressure belt regions towards the intertropical convergence zone, you have onshore trade winds along the eastern continental margins, which leads to heavy precipitation along the eastern margins of the continents. Contrary to this, the western continental margins in the tropical areas have offshore trade winds because the trade winds blow out from these regions, leading to low precipitation along the western margins. So the trade winds are onshore along the eastern continental margins in the tropical areas, whereas they are offshore along the western continental margins in the tropical areas, affecting the rainfall regime in the tropical areas. Besides this, the trade winds, as per the earlier belief, were considered to be the regular winds which blow throughout the year. However, the regularity is questioned due to recent researches, and now it is considered that the trade winds only blow with regularity over some parts of the tropical regions and are not always zonal in characters, and the regularity of antitrades which are confined to the upper atmospheric regions in these tropical zones is also not continuous. Besides this, the weather conditions in the tropical regions are not uniform. Rather, they are interrupted by several atmospheric disturbances, formation of thunderstorms, formation of convective cells, and formation of extreme weather events like tropical cyclones and hurricanes are also frequent in these areas. So along these trade wind belt zones, you have extreme atmospheric disturbances conditions also because of intensive insolation and existing convective mechanism in these areas. Besides trade winds, you have equatorial westerlies or doldrums which exist in the equatorial trough region, which extends between 5 degrees north and 5 degrees south of equator. Equatorial trough, which is a belt of low pressure, extends between 5 degrees north and 5 degrees south of equator, which is a calm region called as doldrum. So light and variable winds which circulate from west to east in the equatorial low pressure trough region or within the ITCZ are called as equatorial westerlies. So as you can see in this particular diagram that they blow from west to east within the intertropical convergence zone. You have the trade winds which are converging in these areas in these intertropical convergence zone coming from subtropical high pressure belt region towards these equatorial low pressure belt regions. As the trade winds converge and ascend, the central part is a calm zone in the equatorial area where these light and variable winds blow from west to east, which are called as equatorial westerlies. And their circulation is subjected to seasonal variation with the northward and southward shift of ITCZ, with the apparent movement of the sun in the northern hemisphere during the summer solstice and in the southern hemisphere during the winter solstice. The ITCZ also shift northward and southward respectively, and the winds which blow in the central intertropical convergence zone also shift north and southward with the northward and southward shift of ITCZ. So the belt is not continuous and is confined to certain localities. According to Fohn, it covers somewhere around 200-degree longitudes extending from Western Africa across Indian Ocean and Western Pacific Ocean region in the intertropical convergence zone. So you have this whole area which extends from Western Africa across the Indian Ocean towards the Western Pacific Ocean in this intertropical convergence zone, which is dominated by the equatorial westerlies. Now coming to the wind circulation in the horse latitudes or the temperate latitudes of the world. So dynamically induced subtropical high pressure belt extend between 30 to 35 degrees in both the hemispheres. And besides this, subpolar low pressure belt exists between 60 to 65 degrees in both the hemispheres. The subtropical high pressure belt zone is a ridge that demarcates area of air divergence at the ground surface. So because of descending air from the upper atmosphere in these regions in both the hemispheres, you have subtropical high pressure belt, because of which anticyclonic conditions prevail at the ground surface and these regions experience divergence of wind at the ground surface. So one wing moves towards the equatorial low pressure belt and they are called as trade winds as we have studied in the earlier slide. Another wing move from the subtropical high pressure belt toward the subpolar low pressure belts in both the hemisphere. And these wind systems which blow from subtropical high pressure belt towards the subpolar low pressure belts are called as westerlies. Thus, this zone separates two wind systems. One is trade wind system of the tropical areas and another one is the temperate wind circulation which blows in the area between 40 to 60 degree latitudes in both the hemispheres. So westerly winds are the permanent wind which blow from west to east. So the general direction is from west to east from subtropical high pressure belt that exist at 30 to 35 degree latitudes in both the hemispheres towards the subpolar low pressure belt that exists between 60 to 65 degree latitudes in both the hemispheres. Westerlies are permanent winds which blow in the temperate regions of the world. The equatorward side of the westerly wind belt in both the hemispheres actually have high pressure. Okay, and the poleward side of the winds have the low pressure. So in these 30 to 35-degree latitudes, in the earlier times, people have to throw their horses in water because the winds were so calm because of existing anticyclonic conditions around 30 to 35-degree north and south latitudes in both the hemisphere. The air was so calm, the sea was so calm that it was nearly impossible for the ships to move. In order to move the ships, the merchants used to throw their horses in sea, and hence the name is the horse latitudes. The general direction of westerly winds is from southwest to northeast in the northern hemisphere and from northwest to southeast in the southern hemisphere. The poleward part of westerlies is always associated with the formation of fronts, as the cold winds which come from the polar areas of the world try to converge with the westerly wind systems, leading to the formation of extensive frontal zones in these temperate regions of the world in both the hemispheres. These fronts are associated with cyclonic activity and are dominated by temperate cyclones, which greatly affect the weather conditions in these temperate regions of the world in both the hemispheres. The general characteristics of westerlies, therefore, is greatly modified due to existing cyclonic conditions, especially along the poleward regions where they are constantly mixing and merging with the cold wind which is coming from the polar areas. And towards their equatorial side, they are influenced by the anticyclonic conditions. So they have mixed characteristic features where on their poleward part they have cyclonic conditions and towards the equatorial part they have anticyclonic conditions. And these westerlies brings much precipitation in the western part of the continent. Contrary to the trade winds which were blowing from east to west, therefore the maximum precipitation was along the eastern margins of the continent. Contrary to that, the westerlies generally blow from west to east. Therefore, maximum precipitation is received along the western margins of the continent in these areas of the world. These westerlies are more extensively developed in the southern hemisphere due to dominance of oceans, and their circulation is much more complex in the northern hemisphere due to dominance of land surfaces. And as you move polewards, their velocity increases. They are known by different names because of the increasing velocity as they move polewards. They are known as roaring 40s at 40-degree south latitudes, furious 50s at 50-degree south latitudes, and striking 60s at 60-degree south latitude, as they are more extensively developed in the southern hemisphere due to dominance of oceans. Now, coming to the wind circulation in the higher latitudes or polar latitudes of the world. As we know that the polar regions do not receive direct insolation, therefore the temperature in these areas remain very low throughout the year, because of which high pressure exists in the northern polar regions also and southern polar regions also. And both the high pressure belts in both the hemispheres is thermally induced, and because of the high pressure existing near the ground, the winds diverge. They blow out from these areas near the ground surface because of the anticyclonic conditions near the ground surface. Consequently, the winds move from the polar high pressure regions towards the subpolar low pressure belt regions, which are located somewhere around 60 to 65-degree latitudes in both the hemispheres. These winds are primarily east-west blowing winds. Okay, their general direction is from east to west. These extremely cold winds which blow in east-west direction, and they blow from the polar high pressure belts regions of the world towards the subpolar low pressure belts regions located at 60 to 65 degrees in both the hemisphere are called as polar easterlies. But this particular belt shrinks dramatically during the northern summer season or during the summer solstice, primarily because of the northward shifting of all the pressure belts during the northern summer season to higher latitudinal areas. So in that condition, the area which is under the influence of polar easterlies is greatly reduced. However, the situation changes due to the southward shifting of the pressure belts during the winter solstice. That is when you have winters in the northern hemisphere and summers in the southern hemisphere. So as the belts again shift southward, the polar easterlies re-establishes themselves in the regions extending between the polar areas and subpolar low pressure belt zones. Besides this, the equatorward portion of these winds is greatly influenced by the westerlies, which blow from the lower latitudes. Therefore, these zones are also marked by the formation of fronts or frontal cyclonic activity also, because of which these regions experience dramatic changes in the weather conditions, especially located around the temperate regions of the world around 60 to 65-degree latitudes in both the hemispheres. Because of the convergence of contrasting air masses, where one air mass is very cold coming from the polar high pressure belt regions, other air mass is comparatively warmer which comes from the lower tropical areas. Therefore, the convergence of both these winds, which vary tremendously in their characteristics, it leads to the formation of fronts and extensive weather systems in form of temperate cyclones along the temperate regions of the world. So we will be covering temperate cyclones in the coming videos. But polar easterlies are the primary winds which blow from polar high pressure belt regions to subpolar low pressure belt regions in the higher latitudes in both the hemispheres. Now, coming to the seasonal shifting of pressure belts and their climatic significance. As we know that the Earth revolves around the Sun in an elliptical path during the period of 1 year, which means that during some time period of the year, the Earth will be closer to the Sun, while at other time periods it will be farther from the Sun. We also know that our Earth is revolving around the Sun and is tilted at 23.5 degrees on its axis, which leads to variation in the amount of insolation which is received in the northern regions as well as in the southern regions. The relative position of tilted rotating Earth changes in relation to the Sun as the Earth revolves around the Sun during the 1 year's time period. That is, during the summer solstice, the northern portion of the Earth is facing the Sun, because of which the northern hemisphere receives more insolation as the Sun is overhead the Tropic of Cancer. But as the Earth continued to revolve around the Sun during the December solstice, the southern portion of the Earth is facing the Sun. That is, the Sun is overhead the Tropic of Capricorn. And you have summers in the southern hemisphere while you have winters in the northern hemisphere. So as the Earth continued to revolve around the Sun, the summer solstice and winter solstice mark the apparent movement of the Sun towards the northern hemisphere and southern hemisphere respectively. Why do we use the term apparent northward movement of the Sun? Because actually the Sun is not moving. It is the Earth which is revolving around the Sun, and it is the position of Earth which is shifting. But from our perspective of understanding, we use the term northward movement of the Sun when the Sun is overhead the Tropic of Cancer in the northern hemisphere, and we use the term apparent southward movement of the Sun when the Sun is over the Tropic of Capricorn, and there are summers in the southern hemisphere. So with the apparent northward and southward movement of the sun, the temperature conditions definitely in both the hemisphere fluctuate. And along with the fluctuations in the temperature conditions, the pressure and wind belts also tend to shift. So when the sun is over the Tropic of Cancer, all the pressure belts tend to shift northward, while when there is apparent southward movement of the sun and the sun is over the Tropic of Capricorn, all the pressure belts tend to shift southward. While all the pressure belts shift northward and southward, the polar high pressure belts in both the hemisphere remain stationary and does not shift northward or southward with the apparent movement of the sun. So when the sun is overhead the Tropic of Capricorn, all the pressure belts shift southward except the polar high pressure belt. And same goes for the northern hemisphere also. When the sun is over the Tropic of Cancer, all the pressure belts shifts northward except the polar high pressure belt, which remain stationary. And this shifting of pressure belts and wind belts create unique climatic and weather conditions in different regions of the world. In tropical areas, they manifest a different type of weather and climatic systems, while in temperate regions, they manifest a unique climatic conditions, especially along the western coast of the continents. And in the polar areas, also two types of wind systems can be seen dominating different time periods of the year. So, shifting of pressure belts lead to significant climatic and weather changes along different latitudes of the region. So let's just quickly see what are the major climatic changes we experience in different latitudes of the world with the shifting of pressure and wind belts. Along the tropical latitudes where the shifting of pressure belts is more pronounced, the shifting of pressure belts leads to very dramatic weather conditions. Specifically, it leads to the onset and origin of monsoon. So a very unique type of climatic system emerges because of the periodic northward and southward migration of pressure and wind belts. And this system is best developed over the Indian subcontinent near the Indian Ocean. So the monsoon climate, especially along the Indian subcontinent, is the result of shifting of pressure and wind belts. As we know that all the pressure belts move northward with the apparent movement of the sun during the summer solstice. So along with all the pressure belts, the ITCZ, where the northeast trade winds and southeast trade wind converge, it also tend to shift northward and it becomes North Intertropical Convergence Zone, and it establishes itself somewhere around 30 to 35 degree north latitude in the northern hemisphere. Similarly, during the winter solstice, that is when you have winters in the northern hemisphere and summers in the southern hemisphere, with the apparent southward movement of the sun, all the pressure belts also tend to shift southward. So the North Intertropical Convergence Zone also shifts southward, establishing itself somewhere around 10 to 15 degree south latitude in the southern hemisphere. So now it becomes South Intertropical Convergence Zone, and the trade winds they converge along this region. But this shifting leads to a very dramatic type of climatic conditions along the Indian subcontinent. So during the January time period, when the intertropical convergence zone is somewhere located just south to the geographical equator, the northeast trade winds they converge along this particular intertropical convergence zones from north, and southeast trade winds they converge from south. But when you have summer solstice and when the intertropical convergence zone establishes itself somewhere around 30 to 35 degree north latitude in the northern hemisphere, then the converging northeast trade winds are pushed further northward in the northern hemisphere, and southeast trade winds which are located south of the equator are also attracted towards this intertropical convergence zone. So now these southeast trade winds, in order to merge at intertropical convergence zone, they cross the equator. And as soon as they cross the equator, they deflect to their right because of the existing Coriolis force when they enter the northern hemisphere. Therefore, their direction becomes from southeast to southwest trade winds, and they continue their northward journey in order to merge with northeast trade winds at the intertropical convergence zone, which has now established itself somewhere around the northern plains of India. And in this northward journey, they pick up a lot of moisture from the Arabian Sea region and the Bay of Bengal region, causing massive precipitation, especially along the eastern and western coastal areas of Indian subcontinent. So the southeast trade winds crosses equator and become southwest trade winds, and they pick up moisture on their way to merge at the north intertropical convergence zone, and in the process they pick up moisture from the Arabian Sea region and the Bay of Bengal region, causing massive precipitation, especially along the coastal regions of Indian subcontinent, leading to the onset of monsoon. During this 4 months time period from June to September, India receives nearly 80% of its rainfall from this southwest monsoon only. Therefore, you can see that the migration of pressure belts lead to 180-degree reversal of wind system in this particular zone of the tropical latitude, thus manifesting unique weather conditions which are best developed over the Indian subcontinent and known as the monsoon type of climate or simply monsoons. So monsoon type of climate is one of the best examples how shifting of pressure belts can lead to 180-degree reversal of wind system, creating a very unique type of environment, unique type of weather system. Besides monsoon, the genesis of Mediterranean type of climate is also associated with the periodic shifting of pressure belts. So during the summer season, that is the respective summer seasons in both the hemispheres, the western part of the continent fall under the offshore trade winds as the subtropical high pressure belt zone extend to 40 degrees latitude in both the hemisphere during their respective summer seasons. Therefore, the western part of the continent within the zone of 30 to 45-degree latitude in both the hemispheres do not receive rainfall during their respective summer seasons. So as you can see in this particular diagram, you have summer season in the northern hemisphere and you have winters in the southern hemisphere. So if you have summers in the northern hemisphere, and the subtropical high pressure belt zone extend to 40-degree latitudes, you have offshore trade winds and the westerlies are blowing above the 45-degree north latitude. Contrary to this, just observe that the westerlies are onshore during the winter time period in the southern hemisphere. But as the sun shifts southward with the onset of winter solstice in the northern hemisphere, the subtropical high pressure belt shifts equatorwards along with the offshore trade winds. Just observe the shifting of pressure belts southward during the northern winter season. So with the southward shift of the subtropical high pressure belt, the trade wind also shifts southward. Just observe now this zone has come under the influence of onshore westerly winds during the winter season in the northern hemisphere. And during this time period, since the westerlies are onshore, these regions receive heavy precipitation. Therefore, the Mediterranean regions receive winter rainfall and have dry season in the summers. Now, contrary to this, just observe the condition in the southern hemisphere. So, if you have winters in the northern hemisphere, you have summers in the southern hemisphere. Now, while the westerlies were onshore during the southern winters, now with the southward shift of the subtropical high pressure belt, the trade winds dominate this region again during the summer season in the southern hemisphere. So you have offshore trade winds in the southern hemisphere now during summer season. So this region here does not receive rainfall during the summer season. Again, observe how the westerlies in these zones have been pushed poleward, and the region comes under the influence of offshore trade winds with the southward movement of the subtropical high pressure belt during the summers in the southern hemisphere. Therefore, the Mediterranean type of climate is experienced between 30 to 45-degree latitude in both the hemispheres during the winter season, where you have wet winters because of the onshore westerly winds, and you have summer dry seasons because of offshore trade winds in these regions. And this is all because of the shifting of air and pressure belts on Earth. So you can see clearly that the shifting of pressure and air belts lead to unique climate called the Mediterranean type of climate. Besides the climatic influence of the shifting of pressure belts in the temperate and tropical latitudes, the weather changes can also be observed in the higher latitudes. So because of the shifting of pressure belts, the region between 60 to 70-degree latitude also experience two types of wind circulation in 1 year's time period. So with the poleward migration of the belt during the summer solstice, the westerlies extend over these areas in the northern hemisphere, while in the southern hemisphere, the polar easterlies extend to large portion due to equatorward shift of the belt. So when you have summer solstice, that is, you have summer season in the northern hemisphere, and opposite to that, you have winter season in the southern hemisphere. So because of the apparent movement of the sun towards the northern hemisphere during the summer solstice, all the pressure belts and winds tend to move northward. So during this time period, the westerlies blow over the large portions in these latitudes, and the polar easterlies in the northern hemisphere are squeezed to small regions in the higher latitudes. And opposite to this, the polar easterlies are quite extensive in the southern hemisphere because of the prevailing winter conditions in the southern hemisphere and because of the equatorward shift of the pressure belts as the result of the apparent northward movement of the sun during the summer season in the northern hemisphere. Besides this, the situation is reversed, as you can see, with the winter solstice, that is when you have winters in the northern hemisphere, the sun is over the Tropic of Capricorn, that is the southern hemisphere receives more insolation. So all these belts tend to shift towards the southern hemisphere, and the situation is reversed, which leads to shifting of winds also. Just observe how with the shifting of pressure belts, the westerlies have also shifted equatorwards, and the entire region which was earlier under the influence of westerlies, now the polar easterlies are re-established in these areas which lie between 60 to 70-degree latitudes in the northern hemisphere. And opposite to this, just observe how the westerlies shift southward with the poleward movement of the pressure belts in the southern hemisphere during summer season in the southern hemisphere. So these regions which are located in the higher latitude extending between 60 to 70-degree latitude also experience two types of wind circulation, where you have wet summer conditions during the summer season because of the onshore westerlies, which brings precipitation along with it because it comes from the lower latitudes. And during the winter season, because of the southward shift of the pressure belts, the dry and cold conditions prevail again. And the polar easterlies, which are very, very cold and chilly, they establish themselves in these latitudes which extend between 60 to 70 degree latitude. Besides this, these areas also experience frontal activity because of the contrasting characteristics of the polar easterlies in comparison to the westerlies. So these regions of the world also experience the formation of fronts, which are formed because of the convergence of two contrasting air masses, that is the westerlies which come from the lower latitude and polar easterlies which are coming from very high cold latitudes in the polar regions. So these areas, because of seasonal shifting of pressure belts, they also experience two types of weather conditions along with certain unique conditions also, just like the formation of fronts and formation of cyclones, which impact the weather conditions greatly in these latitudinal belts. So seasonal shifting of pressure belts not only changes the weather conditions in high latitude, but it also governs the precipitation regime and the overall climatic conditions which we experience in these higher latitudinal regions of the world also. Summarizing the video now, so as we have discussed, wind is the horizontal movement of air which is caused by the differences in air pressure in different regions within our atmosphere. And winds based on their periodicity of occurrence and location of occurrence are primarily divided into three categories. First one is the primary winds, which have global dimension, which are regular and they blow constantly. Then we have secondary winds, which are periodically experienced. And then finally, we have the tertiary winds, which are experienced at the local level and they are influenced by the local changes in the pressure and temperature conditions. So, all these conditions in all these winds, as we move from primary winds to secondary winds and tertiary winds, the scale of their circulation also changes, where you have global circulation at the primary winds level, then you have the regional circulation at the secondary winds level, and then finally the tertiary winds cover the local area influenced by the local conditions. So when we discuss the planetary wind systems, we have to first understand that their circulation depends upon the existence of high pressure belts and low pressure belts which exist latitudinally on our Earth. So latitudinally, we have 7 pressure belts which exist on our Earth and their position is more or less stationary, which affect the movement of planetary winds. So you have dynamically induced pressure belts also and you have thermally induced pressure belts also, which greatly affect the movement of planetary winds, because planetary winds always move from the regions of high pressure belts towards the low pressure belt regions. So primary winds can be further divided into three parts depending upon the latitudinal extent they cover. That is, there are certain winds which blow over the tropics, just like trade winds, and you have equatorial westerlies which blow in the tropical zone. Then you have the winds of the temperate regions, which include the westerly winds, and finally we have winds of the polar areas, which are called as polar easterlies. So besides the existence of these winds, the apparent migration of sun due to Earth's revolution and tilting of Earth causes seasonal shift of pressure belts and wind systems also. And this periodic shifting of pressure and wind belts causes changes in weather and climatic conditions of several regions across the globe. So in different latitudinal extent, the shifting of pressure belts causes different type of climatic conditions. For example, in the tropic, it changes the position of intertropical convergence zone, which moves northward with the apparent northward movement of the sun, and it shifts southward with the southward movement of the sun. And it affects the monsoonal regime, specifically over the Indian subcontinent. While in the temperate regions, the shifting is associated with the genesis of Mediterranean type of climate. And in the higher latitudes, the intensity and periodicity of polar easterlies is also influenced by the shifting of pressure and wind belts northward and southward. So in 60 to 70 degree latitudes in both the hemisphere, the regions experience dominance of polar easterlies during the winter season, while during the summer season, these areas experience the westerlies because of the northward shift of the pressure belts during the summer season. And therefore, the shifting pattern influence greatly the velocity, direction, periodicity of wind movement, precipitation regime, and overall weather conditions across several latitudes on Earth's surface, affecting flora, fauna, ecosystem. You have different type of climatic conditions, you have different floristic regions, evolution of different ecosystems also, which are found in different latitudes. Therefore, the study of wind circulation at global, regional, and local level is very, very important, and it is the key element of climatology because it defines the general atmospheric circulation pattern at the macro level and even at the micro level on Earth. So, because of the wind circulation, you have different types of atmospheric circulation, atmospheric conditions which exist at the global level or the regional level and even at the local level, and all of them are very unique. They differ from one another, but at the same time they greatly influence one another, also defining the overall climatic system of the Earth. So this was all about the planetary wind circulation, the movement of different types of winds in tropical, temperate, and higher latitudes of the world, and how they interact together in creating unique atmospheric and climatic systems which vary from place to place, but at the same time they exert great influence on each other also in defining the overall climatic conditions of our planet. In our next video lecture, we will be taking up the regional wind systems and local wind systems. So I hope the video was informative. Thank you so much.